Okay, so welcome to this video in which we're going to look at differentiation by first principles. And really, differential calculus is all around finding gradients. And what we are going to try and do here is we're going to try and find the gradient of this curve, right, at this point over here. At this point x, f of x. Okay. That gradient is called the instantaneous gradient because what we can see is that the gradient's actually changing as we move along the curve. The curve's actually getting steeper as we go, right? But we want to know the gradient at this particular point. It actually will be the same as the gradient of this tangent line at that point. So in other words, what we're really trying to find is the gradient of this red line. Okay, what we know about gradients so far is that if we've got 2 points, a point here and a point over here, then we can find the gradient of this blue dotted line using our normal kind of gradient formula, which is change in y divided by change in x. So in other words, 2 y values subtracted divided by the corresponding x values subtracted. Right, that's what the formula that we get given for gradient. Right, and that will give us the average gradient between those 2 points. All right, now what we're going to look at, once we've written down our sort of gradient formula, in fact, let's do that now. So let's take our other point a little bit further away at x plus h. So we're just going kind of h units further across, and the y value would be f of x plus h. So if we find the average gradient using those 2 points, it will look like this. It will be y value minus y value over the corresponding x values subtracted. X plus h minus x. In other words, this x value minus this x value. Right. That obviously simplifies to f of x plus h minus f of x over h. Right. Now, let's take a look. If we were to bring this point, the second point, a little bit closer, what we can see is that this blue line, the gradient of the blue line, is becoming a better and better approximation of the gradient of the red line. Right? Remember, we're trying to find the gradient of the red line. So the question is, well, how big do we want h to be? And the answer is that we actually want h to be as small as it possibly can be. H can't be 0, right? If h was 0, then we'd have a division by 0, and we'd only have 1 point, and we wouldn't be able to use our gradient formula, all right? But we want h to be as small as possible. So what we do now is we work out the limit as h approaches 0. Right, and this formula gets provided to us on the formula sheet in terms of a means of finding the gradient of the function f at the point x. Okay, let's dive into a specific example, right? So we're going to use this formula, right? We've got a point over here, x, and now in this particular case, our function is negative x squared plus 3x plus 2. So the y value will be negative x squared plus 3x plus 2. And this y value over here at x plus h will be the negative of x plus h squared plus 3 lots of x plus h plus 2. Okay, and so now what we're going to do is we're going to work out the gradient at this point over here using this formula. So f dashed of x will equal the limit as h approaches 0 of this y value minus this y value. Over the x values subtracted. And remember, the x values subtracted just give us h. Okay, now what we're going to do now is we're going to just simplify everything on the numerator. Right, we're going to square out x plus h properly. And remember, when we square properly, we get x squared, we get 2xh, we get h squared. Then we've got 3x plus 3h. Then we've got a plus 2. Then we've got minus negative x squared, so it's actually positive x squared. We've got negative minus positive 3x and minus 3x minus 2. All over h. Okay, right. When we take out these brackets, we actually end up with negative x squared minus 2xh minus h squared plus 3x plus 3h plus 2 plus x squared minus 3x minus 2. Right, and what happens now is that in fact a number of these terms actually cancel one another out. And in fact anything that doesn't have an h in needs to disappear, and we'll explain why that's the case just now. So the 3x and the minus 3x, the 2 and the minus 2. Now we are interested in how this fraction behaves when h gets very, very close to 0. Remember that we want the second point to be very close to the first point. Okay, we've got a problem because we can't let h be 0. If we let h be 0, we actually get 0 on the top and 0 on the bottom, and that's undefined. Right, but what we can do is we can factor out an h on the top. Right, in which case we get negative 2x minus h plus 3 over h. Because h is not 0, we can actually now divide the numerator by h and the denominator by h. Right, so what we've now got is the limit as h approaches 0 of negative 2x minus h plus 3. Now, as h gets very, very small, right, this limit will just start to look like minus 2x plus 3. And that's our final answer. So this expression here, minus 2x plus 3, gives us the gradient of f at any value of x. Okay, so we can find the gradient at any value of x by just choosing a value of x and calculating the gradient. Okay, just a few things about this. Because this is almost like a piece of theory, it's marked very strictly in the sense that we need to have the word limit h tends to 0 on every single line apart from the last line. Wherever h appears, limit as h approaches 0 must appear. We never put the equal signs in here, right? Between the limit and the expression, they go on the left-hand side. At the line where we've now got kind of multiple terms, these brackets are absolutely essential. If we were to leave these brackets out, we would lose a mark because it's similar to the distinction between, say, sine of 60 plus 2 and the sine of 60 plus 2. On the top line, we're just finding the sine of 60 and then adding 2. On the bottom line, we're finding the sine of 62. What we need is we need to find the limit of all of this stuff. So those brackets are absolutely essential. Another thing that we must never do is suggest that h actually equals 0. So it would be a problem here to write minus 0 and actually let h be 0, because h cannot be 0. We are interested in how this thing behaves when h gets very, very close to 0. We're interested in what we call the limit. Right, so while you might in your head say h is 0, don't write down that h is 0. Okay, that brings us to the end of this little video. Remember that if you found it useful, please subscribe, share, and like. Thank you.